The evolution of .NET, from ASP Classic to the latest .NET Core, is a fascinating journey that reflects the need for improved performance, scalability, flexibility, cross-platform compatibility, and modern development practices. Here's an in-depth exploration of the evolution, challenges faced, and why each change was essential. ASP Classic, introduced in 1996 with iOS 3.0, was one of the first technologies for building dynamic web pages. It allowed developers to embed server-side script into HTML pages using VBScript, JavaScript, or other scripting languages. ASP Classic was Microsoft's answer to competing technologies like PHP and Java Server Pages, or JSP. Key features: simple, easy-to-use scripting model, tight coupling with iOS, Internet Information Services, limited support for object-oriented programming, or OOP, single-threaded and lacked true support for modern web development patterns. Challenges: performance issues. ASP Classic was single-threaded, and as applications grew, it became inefficient at handling large numbers of concurrent requests. Scalability: it did not provide an easy way to scale applications, especially when the traffic increased. Lack of separation of concerns. Business logic and presentation were often tightly coupled, making maintenance difficult. Limited development models. It lacked modern features like structured object-oriented programming, security frameworks, and code reusability. Evolution. Drivers: the rise of more modern, efficient frameworks like PHP and the increased need for modularity and scalability in web applications. The limitations of the ASP Classic model in handling modern application complexity. ASP.NET was introduced in 2002 as part of the .NET framework. It marked a major departure from ASP Classic by providing a compiled, strongly typed environment with rich libraries, better security, and the ability to use languages like C# and VB.NET. ASP.NET introduced the concept of web forms and MVC, or Model View Controller. Key features are web forms, a drag-and-drop interface for rapid application development. MVC Model View Controller, introduced as an alternative to web forms, allowing for better separation of concerns and adherence to design patterns. State management, introduction of better state management using session, cookies, and view state. Robust security. Built-in security features like authentication, authorization, and encryption. Page lifecycle. A structured flow for handling page requests, events, and controls. Challenges. Complexity with web forms. Web forms, while powerful, often led to poorly structured code. The event-driven model was hard to scale and manage, especially for large applications. Performance. The heavy reliance on view state to maintain state across requests led to large page sizes and slower performance. Limited cross-platform compatibility. ASP.NET ran only on Windows, limiting its reach and the ability to scale horizontally on different platforms. Evolution drivers. The growing demand for better performance and scalability. The desire to move away from the complex web forms model and provide developers with a more lightweight, flexible framework for building web applications. ASP.NET MVC, first released in 2009, addressed many of the limitations of web forms by introducing a more lightweight, testable, and maintainable architecture. It emphasized the separation of concerns and allowed developers to have more control over the request pipeline. Key features: MVC pattern, separation of concerns between model, view, and controller. URL routing, clean, SEO-friendly URLs. Full control over HTML. Developers had full control over the HTML output, making it easier to create modern user interfaces. Testability, easier to write unit tests for applications built with the MVC pattern. Challenges: while ASP.NET MVC offered flexibility, it also introduced complexity for beginners, requiring more configuration and setup compared to web forms. Evolution drivers. The demand for more control over HTML rendering, better testability, and cleaner, more maintainable code. the growing trend of single-page applications or SPAs, and the need for modern web development practices like REST APIs. .NET Core was introduced by Microsoft as a cross-platform open-source rewrite of the .NET framework. .NET Core was designed to be modular, lightweight, and capable of running on Windows, macOS, and Linux. It broke away from the old .NET framework, which was primarily Windows only. Key features: cross-platform, run applications on Windows, Linux, and macOS. Performance: significant performance improvements, making .NET Core one of the fastest frameworks for web development. Modular: .NET Core introduced a modular design where only necessary libraries are included, reducing the application's footprint. Dependency injection: built-in support for DI, which improved the modularity and testability of applications. Lightweight and flexible applications could be smaller and more efficient, especially in cloud-based environments. Open source: .NET Core was fully open source, encouraging community contributions and transparency. Challenges: breaking changes. Transitioning from the full .NET framework to .NET Core was not trivial, as there were many breaking changes in APIs, libraries, and project structures. Tooling: early versions of .NET Core lacked some features and tools available in the .NET framework, requiring workarounds. Evolution drivers: the rise of containerization such as Docker, and the need for lightweight cross-platform solutions that could run on any operating system. The growing need for cloud-native applications and microservices. The shift toward open-source development practices and the desire to avoid vendor lock-in. .NET 5 unified the .NET Core and .NET framework into a single platform, providing a modern development experience across web, mobile, desktop, and cloud applications. From .NET 5 onwards, the .NET Core name was retired in favor of simply .NET. Key features: unified platform, a single platform for all application types, web, mobile, desktop, cloud, IoT, and so on. Improved performance. Further optimizations in runtime performance and garbage collection. C# enhancements. New language features like records, pattern matching, and async streams. Cloud ready. More focus on developing cloud-native applications with support for containers and microservices. Long-term support. Microsoft offers long-term support for these versions, ensuring stability and security. Challenges: backward compatibility. Despite the unification, developers face challenges migrating older .NET framework applications to .NET 5 and beyond. Evolution drivers. The need for a truly unified framework for all kinds of application development, mobile, web, desktop, etc. The increasing importance of cloud-native, microservices-oriented architectures. Increased focus on cloud-native architectures. As cloud computing grows, .NET will continue to evolve with tools that enhance microservices, Kubernetes, and containerized applications. More cross-platform features. Continued improvements for cross-platform development with better support for mobile and desktop apps using .NET MAUI or multi-platform app UI. Further simplification. The trend towards simplifying development will likely continue with enhancements to DI, testing, and overall architecture. Performance and scalability. .NET will continue to push the boundaries of performance and scalability, especially for high-demand applications. Artificial intelligence and machine learning. Expect better integration with AI and ML frameworks as these technologies become more central to application development. Conclusion. The evolution from ASP Classic to .NET Core was driven by the need for better performance, scalability, cross-platform support, modern development paradigms, and cloud readiness. Each transition solved specific challenges, such as simplifying development, improving security, enhancing performance, and embracing open-source collaboration. As new challenges arise, such as the need for containerization and microservices, the evolution will continue. But the key principle remains: simplifying development and ensuring that .NET can tackle the next generation of application challenges effectively.